welcome to our channel. This video will be continuation of part 1, the structure of atom. So let's see, atomic model of Thomson. J.J. Thomson discovered electrons first, then he proposed a model of atom. This atom was similar to Christmas pudding. See this is a Christmas pudding. He considered this as the positive sphere and the round-like structure is negative, that is electrons. He said that this positive and negative will combine and neutralize the atom as whole. See, this is a watermelon. He also told the example for this. The red edible part is the positive charge and the black seeds are the electrons. So his final observations are the atomic structure is neutralized as whole. Next we will see atomic model of Rutherford. His full name was Ernest Rutherford. He was interested to know how that electrons are distributed in an atom. So he decided to do an experiment. He chosen a thin gold foil and alpha particles, that is doubly charged helium, for his experiment. His expectation was the particles would be deflected by the atoms of gold foil, but the observations turned quite opposite to it. See, this is the alpha particle emitter. From this the alpha particles will produce. See, this is a slit. This is used for the gold foil. This is a gold foil. The alpha particles going, but some only got into through it and some are deflected and some of them are rebound. This was the observations of Rutherford's atomic model. Atomic model of Neil Bohr. Neil Bohr, he was wanted to remove the drawbacks of Rutherford model because Rutherford's model also was failure, because he also said that protons and electrons will move and per particular stage will come that the electrons lose its charge and make the atom as neutral. So he wanted to remove the drawbacks. So he postulated a diagram of model of atom. See, this was the diagram. He told that each orbit has K shell, L shell, M shell and L shell, each has a power in it. K shell n is equal to 1, L shell n is equal to 2, M n is equal to 3 and n is equal to 4. His atomic model got more success than the other two. Next, how electrons are distributed in the shell. Because the distribution of cells must have the rules. Because as it is, we cannot decide how electrons are distributed. So the rules to write number of electrons in shells are: the maximum number of electrons in shells is given by 2n square. N is represented as the energy of the shells. We saw that Kn is equal to 1, like that. So 2 into 1 square is 2. So that the K shell can accommodate 2 electrons in it. Similarly, orbit 2 has energy 2. So 2 into 2 square, that is 2 into 4, 8 electrons can accommodate it. The maximum number of electrons that can be accommodated in the outermost shell is 8. That is, the shells can accommodate only 8. Then more than if 8, it will be accommodated in the next shell. Electrons are not accommodated in given shells unless inner shells are filled. This shows that shells are filled in a stepwise manner, because as it is, it cannot fill fully. If electrons are not filled in inner shells, it cannot move to the outer shells. If this filled 8 electrons, then only it can move to the third shell. Thank you.